All right, so this last video for Unit 2B is solving trig equations. This is kind of where it all comes together. You can use all your trig identities to help you substitute certain things in. And then you're also going to need to know inverse trig because you're solving for an angle measurement. Okay, so the whole goal is to get that x by itself, but you have to get it out of the trig functions. So something that I found that's really makes things really easy is instead of using sine, cosine, tangent in my equations, I want to substitute that. So I'm going to let y equal sine of x. Okay, so when I do that, I now have 2y squared equals 1. So your first step is to substitute in. Your second step is to get y by itself. Okay, so I'm going to divide by 2, and this is y squared equals 1/2, and then I'm going to say y equals plus or minus the square root of 1/2, and when I rationalize that, I get y equals plus or minus the square root of 2/2. So that's two equations, y equals square root of 2/2 and y equals negative square root of 2/2. Okay, and that makes sense because y was squared. So your third step is going to be to sub sine back in. So this is now sine of x equals square root of 2/2, and sine of x equals negative square root of 2/2. So when I do get x by itself, I need to use the inverse trig. Okay, so the sine inverse of square root of 2/2 is I'm looking for a y coordinate that equals square root of 2/2, and I'm not using principal values because it didn't tell us to, and my sign is lowercase. So the angles that have a y value of square root of 2/2 are going to be 45 degrees and 135 degrees. Okay, and then on the other side, the angles that give me a y value of negative square root of 2/2 are going to be, let's see, 225 degrees and 315 degrees. Okay, I'm just getting that right from your unit circle. It also gave us that I'm going for all x's in between 0 and 2 pi. So that kind of does mean it wants the answers to be in radians. I would never count it wrong if it wasn't, but this could be all converted to radians if you wanted it to be. But you have to have all 4 answers in your answer for it to be correct. All right, so for this example, notice that you've got sine and cosine, and you want to make all of your trig functions the same if at all possible. And this is possible with our Pythagorean identity. So sine squared plus cosine squared equals 1. And I can substitute 1 minus sine squared in for cosine. So this is now sine squared x minus sine x plus 1 equals 1 minus sine squared x. Okay, so now I can go forward with my first step. So let y equal sine of x. So this is y squared minus y plus 1 equals 1 minus y squared. Okay, it's a quadratic, so I need to get everything on the one side. So I'm going to add y squared and subtract 1. This is 2y squared minus y equals 0. Most of these you're going to be able to solve with factoring. I'm going to factor out a GCF of y, and I'm left with 2y minus 1. Okay, when you factor, you get each factor equal to 0 and you solve for y. Okay, so I solved for both y's, and at this point, this is where I'm going to plug sine back in. So sine x equals 0 and sine x equals 1/2. So when I get x by itself, I need to use inverse trig. So sine inverse of 0, that means where's my y coordinate 0? And that is at 0 and 180. Okay, and we want to look at that, and that tells us that I'm going from 0 to 360, not including 360. Okay, so then this x is sine inverse of 1/2. So I'm looking for, on my circle, where's my y coordinate 1/2, and that is at angle 30 degrees and 150 degrees. Okay, so that is my final answer. All right, in this example, we're solving for all real values of x in radians. So I want you guys to remember your coterminal angle formula. It's angle plus 360k. So all my angles need to be put into that formula because it's all real values. Okay, so all of these are in tangent. So I'm going to go ahead and substitute y for tangent. So y squared plus 2y plus 1 equals 0. And I'm going to factor. So this is y plus 1 times y plus 1. And I'm going to set each factor equal to 0. Okay, so I've got y solved for on both of them, and they're the same, so I don't really need to solve for both equations. So I'm just going to do the one on the right. So I'm going to subtangent back in. So tangent of x equals -1. And when I get x by itself, I need to use inverse trig. Okay, so I'm looking for where is my tangent, or where is my y over x, oh, that's really hard to see, equal to -1. So remember that tangent is negative in quadrants 2 and 4. So tangent equals -1 at 135 and 315. Okay, but those are not the only values. I need to make sure that it's all real numbers. So 135 plus 360k and 315 plus 360k is my final answer. All right. Okay, and I could leave it like that, or since every basically 180 degrees is where my tangent repeats, I could just pick one of them. I could say 135 plus 180k, and it would be the same. So either way would be correct. All right, and this is the last example. So in the other ones, if we had something that wasn't the same trig function, we tried to make it the same, and there's no way I can make sine and tangent into each other. So what I can do next is see if I can factor this out to see if I can separate them. And I can actually pull a sine out as a GCF. So I can say sine x, and then when I see what's left, I've got two separate factors with two separate trig functions, so I can do that. In this case, I would not want to substitute my trig functions with other variables because it just kind of makes it more complicated. So this is sine of x equals 0, and this is 1 minus tangent x equals 0. So over here, x equals the sine inverse of 0. And it says I'm using principal values, so I've got to figure out in my principal values what angle gives me a y value of 0, and that's going to be 0 degrees. Okay, over here, I'm going to subtract 1, divide by -1, and x equals the tangent inverse of 1. So in my principal values for tangent, I need to look at the first and fourth quadrant and see what angle gives me a y over x, or a tangent value of 1, and that is going to be 45 degrees. All right, so there's a couple of like the major examples. Again, I've got way more in the worked out notes, so just look through those, and if you need extra practice, like work through them and see if you can follow my steps. But your homework on this is going to be, I believe, an Alex assignment.